Dielectric oil is a type of mineral oil, and what we use is biodegradable, environmentally friendly, all that good stuff. But what it does, it has fantastic capacity to just take away the heat.
And so, does your product have the UL 9540 or UL 9540A or both?
What we have is a 9540 is we've been approved, and we're just getting the paperwork. And then 9540A, interesting enough, they couldn't make our batteries burn, and the test requires the battery to burn. So that's something that UL has been helping us with to figure out how we can do their test. We can heat the system too, and what's great is that with it being in a fluid, we get a much more consistent thermal property with the fluid. So you don't get those hot spots and cold spots on a battery cell as typical. You get a nice consistent thermal pattern with ours. We can keep that temperature and dial it into whatever our customer wants specifically. So different folks actually have different levels of temperature that they want.
And then, what does that come from, Etica AG? What does that stand for?
Sure, it's actually a joint venture, and it's between Etica Battery, which is out of Taiwan, and out of AGI, which is here in the US. And so together, they've joined a new company to get this technology out to the market.
Hello, and welcome to Sean White's Solar and Energy Storage Podcast.
Today, our special guest is Matt Ward, and Matt is the president of Etica AG. And Etica AG does something that sounds really neat. It's battery immersion technology. So, Matt, I was wondering, like battery immersion technology, can I just throw some batteries in the water? Would that do it?
Hey, Sean, how you doing? Throwing batteries in water, I would probably advise against doing that for way too many reasons I could even list.
So I don't want to just fill up the bathtub, and that's not how your company started, I guess.
No, that's definitely not a healthy thing to do. It would land you at the minimum into the emergency room, and at the worst, it could be a lot worse. But no, what we do is that we actually take the batteries and we submerge them in dielectric oil.
Oh, dielectric oil. Okay.
Yeah, same thing that the transformer industry has been using forever. And we've just taken that technology and used it with batteries.
So maybe you could explain, what is dielectric oil?
Dielectric oil is a type of mineral oil, and what we use is biodegradable, environmentally friendly, all that good stuff. But what it does, it has fantastic capacity to just take away the heat. And that's how it goes. So when a battery cell, if it goes into thermal runaway, the oil takes away that heat so that the cell can't get the flame and can't propagate the heat to the next cell and create that cascading effect that creates obviously the fire issue.
So I just looked it up, and dielectric means it's more like an insulator, so it's not a good conductor of electricity. So that's kind of interesting. I wonder if olive oil, what kind of dielectric properties that has. That's what I like to put on my salad.
If we're doing like a cooking channel show, I guess we could do that. But otherwise, probably I wouldn't suggest using olive oil with batteries.
Okay, all right, great. So you've got this special property where you can put your batteries into fluid. You know what happened when I first was reading about the battery immersion technology? For some reason, it made me think of some videos that I was watching. I call it a Bitcoin hot tub. So they take these cryptocurrency miners that create a lot of waste heat, and they use them to heat a hot tub, or they can heat a room with them, something like that. So with this battery immersion technology, so it's taking the heat away from the batteries, can we also have like a battery heated hot tub?
I've never been asked that question before, Sean.
I bet.
So I tell you, let me check with my engineers and I'll get back to you on that.
Okay. Yeah. Because I'd kind of like to do that. I think it's like saving the world and having a hot tub at the same time seems like the right thing to do.
It sounds like a good one, especially on a Friday afternoon after 5.
Yeah. Yep. Okay. And so it's a dielectric oil. And the oil, does it taste good? Do you know? I don't know. Like,
I gotta tell you, I don't know. Not sure if you can put it on your salad. I don't know if I probably wouldn't recommend anyone to ingest it, but it's something where it has a fantastic shelf life, 30 plus year life on its properties, and high flash point, all those good things to just make it safe.
Yeah. And I'd imagine it's probably not really toxic, like if you're dealing with lead batteries or something like that.
Oh, no. The oil itself is all, like I said, biodegradable, environmental friendly and such like that. So no issue there.
And so the kind of applications that you have, Is it going to be more utility scale, C&I, that's commercial and industrial, residential? Where would you put it?
Well, that's the great thing is that the actual battery tech goes across all different industries. Every industry using lithium batteries needs this type of application. Obviously, it's best for areas that, we want to put batteries close to buildings, close to schools, around areas that maybe have hazardous items, and such like that. Because the battery is obviously a lower density on the footprint just
Mm-hmm.
because we have the oil. It takes up more space. So if you're looking for something just to take care of any issue for fire hazard, this would be the product to use.
Great. And so there's different types of propagation. And so what propagation is it's a nice word for one cell catching on fire or having a thermal event. I guess we shouldn't say fire, it doesn't have to have a flame, but to get hot enough to make its neighbor also get hot, like a chain reaction. So does this prevent cell to cell propagation?
It does. And that's the incredible thing about it. It's just the properties of the liquid just absorb that heat so that even though there's the one cell that now has gone on runaway, it's confined to just that cell and it can't go and cause its adjacent neighbors to cascade and so on and so on. So we actually stop right at the source, the potential fire hazard, rather than reacting after the fact after there is a fire hazard.
That's pretty interesting. So for energy storage systems and residential applications, we have the International Residential Code, and there is a special section in there that's for energy storage systems itself. And one of the things is there's a way to get this listed to 9540A and 9540. We could talk a little bit more about that too. But one of the tests that they go through is for propagation, and I don't think anybody else has systems where you can prevent cell-to-cell propagation. What they're just looking at is like one module to the other, or one battery unit to the other. Does that sound right to you?
Well, I mean, right now we're only focused on the U.S. market, but I do know there's a number of great systems out there that have insulators and such between cells to cell and such like that. The biggest item is that ours, the cells are always submerged, they're always surrounded by the liquid. So there's not a matter of concern if it's going to work or not work because it's always there.
Yeah, and another thing too that's kind of interesting about the International Residential Code with energy storage systems is right at the beginning, it says something like you don't have to follow this section if you have something that's listed for use in residential applications. I know they changed it from 2021 to 2024, like the wording, so it might not be exactly that, depending on which one you're looking at, although it just means the same thing. And so far as I know, there's nobody in the world that has ever made something that was actually listed for use, especially for residential. And then that would mean that you could put it anywhere in the house. You wouldn't have to put it in the garage or put it on an outside wall or something like that, or put it in an area where it's not habitable. So that's kind of interesting, or it sounds like a good market for you if you could get it listed that way, where you wouldn't have to follow the special energy storage system section in the International Residential Code.
Well, with immersion tech, it gives us a lot of opportunities and really some neat things that we can do. So that would be just another one to where we can make the batteries just more accessible, more usable, and easier to place.
And so I know some battery systems, they do have liquid cooling and some don't. And yours is actually immersed. And so I guess with the liquid cooling, it would be like there's tubes going in between places, carrying heat out. But you are just like taking this battery cell, I guess, and just dunking it in the dielectric oil.
We put it in the dielectric oil and it stays in the dielectric oil. So we have that portion for the fire safety. Now we do go ahead and circulate the oil too, and it nicely handles the thermal effects so that everything stays nice and cool. But in reality, that's just icing on the cake for what we're trying to do.
That's pretty neat. And I guess oil in general can burn. So I guess this oil doesn't burn probably, or?
No, all oils eventually can burn. It's just, how much heat can it absorb before that happens. So, for ours, the flash point is substantially higher than thermal runaway. So that way we just never get to that point.
So you never get to that point.
Yeah.
And what does it look like inside of this? Like, so you have different battery cells. What kind of cells are they? Like cylindrical, prismatic? Are they pouch cells?
Well, that's the great thing. The tech works on all different types of batteries. And for the ones that we've tested, it's all been cylindrical and prismatic, but it doesn't really matter necessarily on the manufacturer. We can work with a lot of different technologies.
So would it be something like there's a case and then that case has a number of battery cells in it, and then into one side is some of that fluid that's circulating from one side to the next?
Well, actually, it's even simpler than that, John. It's just more the batteries are just put in a bathtub of the oil and they just sit there and they just stay nice and cool.
Mm-hmm. But like you said, you have to circulate the oil?
No, actually, don't have to circulate the oil for its effectiveness. We just do that just to make the thermal properties a little bit more smoother.
Okay, great. And so there doesn't need to be any kind of like oil cooler like I used to have on my Volkswagen.
That's going way back there.
Uh-huh.
No, actually, you don't have to have that.
Okay, great. So that's pretty neat. And then what's the volume or the weight of the oil as far as this goes? Like it must, weighs something, it takes up some space. What would that be compared to the volume and the weight of the batteries?
Yeah, I mean, there is a difference, obviously. We don't go very much into the exact on that, but it does add some significant weight. Obviously, it's a fluid. And so the overall system is definitely heavier than our competitor systems. But obviously, the difference is it makes up on the safety portion.
Yeah, and it's not like you're using them in cars.
No, ours is a stationary application.
Yeah, so the weight doesn't really matter that much when you're setting it down somewhere, not like if it was in a car that you would have to accelerate and decelerate all the time. So that's pretty neat. And then like for one of these, I guess, would you say like you've got the cell and then a bunch of cells make up a module and then a bunch of modules can make a pack, something like that. What are you calling a bunch of cells inside of something?
Yeah, we put a number of cells into a module, and the module is in a cartridge, which is pretty standard fare, and then that makes up the actual container.
And then if you put a bunch of cells in a module, like how many kilowatt hours or watt hours?
Yeah, right now our modules are a little bit less than 20 kilowatt hours.
Okay.
And then you put a number of those in the racks and the containers.
Mm-hmm. And is this something that's being invented more right now? Or like, are you more in the development phase or can somebody go out and buy it?
Oh, no, this is something that we've spent years developing, designing, and testing, and then refining. So we've been doing that a number of years. Very difficult. The solution's very simple, but the actual putting it into reality has been very, very difficult. So we've been doing that for years. The systems are out on the market. We have those deployed overseas, and now we're bringing this here to the United States.
Great, great. And you said it's a lot like how a transformer is cooled. Maybe you could explain even a little bit how a transformer is cooled.
Right. It's the same type of idea where you're putting in those heat making elements into a bath of oil just to dissipate the heat. It lets the equipment last longer, function better, and then take away that issue of fire safety.
And I guess just like with air, heat rises, that also happens with fluids. So that would be one way that all of these fluids would circulate.
Yeah, actually, air operates just like a fluid too, and you get that circulation and such, and it helps mix everything.
Great, great. Okay. So how can people get some of this technology?
Sure, absolutely. Just go to our site, eticaag.com, and get with one of our people on there. We have some fantastic folks that will help you take you through the process and really figure out what product you need. If you already know what product you need, terrific, and we'll get you squared away.
Okay. And so does your product have the UL 9540 or UL 9540A or both?
What we have is a 9540 is we've been approved and we're just getting the paperwork. And then 9540A, interesting enough, they couldn't make our batteries burn, and the test requires the battery to burn. So that's something that UL has been helping us with to figure out how we can do their test, because everyone would like to have that test, but in a way to where we can use the product like it was designed to.
That's something to brag about to people that understand what UL 9540A is. But I guess if somebody didn't understand it, they'd think, oh, you couldn't even take the test. But part of the UL 9540A test is you have to make it catch on fire. And
Yes.
if you can't make it catch on fire, you didn't do the test.
Yeah, so instead of a 9540A is more about collecting the information, but it's one of those ones where we couldn't even get to collecting the information because we couldn't do
Hmm.
the test. But they're helping us on how we can do that test for them.
Yeah, and also another thing about UL 9540A is it's not a pass or fail test. You can't just go, oh, we passed 9540A. What it is they heat up a cell and make it catch on fire and see what that leads to. Or I shouldn't say the F word again either, the fire word. I should say that they make it go into thermal runaway. So they make it get into a hot reaction. And so how would they even try to do that? I know sometimes what some of these battery companies are doing is they're getting like little resistive electric heating elements and they're sticking them in there next to the battery cell. Are they trying to figure out some way to get that battery just like a single cell hot enough and show that it won't catch its neighbor on fire? Or
Yeah.
I said that word again, thermal runaway.
There's all different types of way, but one is exactly like you said, heating up the space at the cell. You can short circuit the cell, but they'll figure out a way. That's what they get paid to do, is to figure out how to test things and make sure that they're safe.
Okay. We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to solarshawn, that's solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show. And where is your factory?
Well, our current factory is over in Taiwan, and then our factory number 2 is in Pennsylvania.
Oh, great. And are you in Pennsylvania?
I'm actually calling you from Atlanta today. Pennsylvania, love it up there. Atlanta, though, it's springtime, and I'm watching the green leaves and the flowers. It's very nice.
All right. Nice, nice. Okay. So is this the kind of thing where you are manufacturing the cells or you're buying cells from somebody else and then putting it inside of your liquid cooled battery box?
Sure. No, we buy the cells already pre-made, and then we put those into our system.
Okay. So are they like, you said you've done cylindrical and prismatic? Are they like 18650s and things like that? That would be 18 by 65 millimeter cylinder?
Yeah, a couple different combinations. Obviously, we have the standard size for what we're introducing into the US right now, but we're just finding that our tech transcends all the different types of batteries.
Okay. And so people will buy these modules, and how are they installing them? Do they just hook them up to an inverter? Do you work with the inverter company?
Well, we have both a DC block solution and an AC solution, so we can have that all taken care of and deliver it right to the customer's project.
Mm-hmm. And so what kind of customers do you have right now?
A variety. We have folks from the residential side up through the CNI and the utility scale. So it really is a wide spectrum of groups that are interested, because the problem is common and consistent throughout the industry.
Mm-hmm.
So it's just, there's, the issue is a number of projects aren't moving forward because of safety concerns. And so this is a solution to their problem.
So there's like certain temperature range for lithium-ion battery cells to operate at. And of course, they don't want to get too hot. And I think that's like the main benefit of your solution. But there's another thing, is they don't want to get too cold, or if they get too cold, they won't work too well. Like if you just wake up in the morning stiff, the chemical reactions are slower. Is there any kind of battery heaters in there too for cold temperatures?
Well, we can heat the system too. And what's great is that with it being in a fluid, we get a much more consistent thermal property with the fluid. So you don't get those hot spots and cold spots on a battery cell as typical. You get a nice consistent thermal pattern with ours.
Yep. And we're going to eventually end up heating up my hot tub. So would that be a good temperature? I like a hot tub that's about 40 degrees Celsius, which is 104 Fahrenheit. What temperature range do you see with your batteries? Where do you like to keep them?
Well, on your hot tub, I probably would want to point you over to our competitors, because they need a way to get rid of their heat.
Uh-huh.
We have already taken care of that problem, so we just wouldn't have enough heat to take care of your hot tub. Sorry on that one.
Okay, darn.
But everyone else has lots of heat to deal with, and they probably would love to hook up to your hot tub.
So what temperatures do your batteries experience?
Well, we can keep that temperature and dial it into whatever our customer wants specifically. So different folks actually have different levels of temperature that they want.
And what might that be? Like the human body is 37 Celsius, 98.6 Fahrenheit. 30 degrees Celsius is 86 Fahrenheit. 25 is 77 Fahrenheit. Just kind of maybe in those ranges, something like that.
In those ranges, like I said, everyone has their own particular specification, which we can handle for them.
Mm-hmm. And do you mostly see people working with lithium iron phosphate type of lithium ion batteries? Is that what you're mostly seeing?
The industry really has moved that way in a big fashion over the last few years. The idea is that the LFP batteries are a bit more stable and safer chemistry than the NMC. And so we see that just continuing.
Mm-hmm. Great. So what are some of your company secrets that we don't want to tell anybody?
Well, we have lots of secrets and we don't have any that we can tell you.
Okay. So you have like patents and all that kind of stuff too.
Exactly. We have patents, we have different assembly procedures and such like that. But like I said, the reality is that what we're doing is very similar to everybody else. All that's different is the immersion portion. But we use LFP batteries, we use the containers, we have the inverters, all of the gear like that is the same.
Mm-hmm. And so you have all of these patents. I've noticed too, like when somebody comes up with a good idea, people will steal their patents and then they'll spend the rest of their life in court. So if your idea is that good, you might end up spending a lot of time in court. For instance, the Wright brothers. I mean, I think those guys they came up with the best invention ever, flying. You can't really beat flying. And then people stole their ideas in different countries and all those kinds of things. And they actually didn't end their lives too well. It seems like they just had a lot of stress and court dates and things like that. So I hope you don't end up like the Wright brothers.
Well, we have a product, like I said, that took years and years to develop and such. So obviously it's going to take a while for someone else to come on the market, but that's expected in any new tech that really changes business as usual. And, we protect our IP just like everyone else would. And that's how it's going to be.
Mm-hmm. And so there's going to be a little BMS in there, battery management system. And like you're saying, you could just dial that up for a particular temperature and it'll stay there.
We'll do that. And then also, obviously, different outside conditions and such between humidities and temperature and climate. That's something that, for the customer, we will dial in what they need in their specifications.
And then where does that waste heat go?
The waste heat it goes into the dielectric oil, and then it gets circulated out and it's diffused.
So when it gets circulated out and it doesn't have like a heat exchanger or anything like that, it's got to go somewhere.
It goes out and then it's released into the ambient. And then with our HVAC system and such, we can pull that out too.
So how does that incorporate with the HVAC?
That's a great question, Sean, and I would love to answer it for you, but I can't.
Okay.
You get a little bit too close to the IP stuff, but
okay. Uh-huh.
One thing though is that we have this system for keeping the flame, propagation, but we do have all the other required systems by code. And not that we'll ever use them, but we have those just required to. So there's actually a couple different ways that we take care of the problem.
All right. And then I guess with transformers, every once in a while, they'll change their oil. Do you have to change the oil on a similar schedule?
We have our own particular schedule, but yes, we have a pretty rigorous O&M program. It's definitely not nearly as labor intensive as other battery systems, but part of that program is to change the oil after about 10 years.
Great. Okay. All right. And I know that sometimes too, they talk about like different types of oils being biodegradable. Vegetable oils are used in transformers, but you're using like a mineral oil. Would it work with a vegetable oil?
That one, I don't know. It'd be interesting to find out. But then again, remember, there's a lot of different things going on when you use these oils as far as on how it reacts with the batteries, the electronics and such. So it wouldn't be just as simple as replacing it with a different type of oil. There's a lot of different tech that goes into that.
Yeah. And then if you were using vegetable oil, we can incorporate like some potatoes. I like my fries like thick cut. That's the way I like them. So,
I thought you were going to go towards, you want to put this oil into the hot tub and maybe get some sun and get a good suntan with the oil, the whole thing like that.
Oh yeah. I don't know if I would want an oil hot tub, how healthy that would be, but maybe some kind of Ayurveda technology there. All right. So what other kinds of things are you working on?
Well, I mean, this right here is actually keeping us quite busy. Tremendous reception as far as on the product and just, people wanting to learn more. So we
Mhm.
spend a lot of our time with our customers. We're out educating all the time just so everyone can understand the tech and what it's doing and how it can be used.
And are you looking to like have your batteries and the battery cooling system incorporated into other systems, like maybe some of the big battery manufacturers out there in the world? Are you looking to work with them and have them just go like, oh, we're going to buy your technology? Or I shouldn't say battery manufacturers, but it could be. But energy storage system manufacturers, things like that, like some of the bigger companies. Are you looking to have them use your technology, like license it to them and stuff like that?
We have a lot of system integrators that want to put our tech into their design. So you pair it with UPS system or you pair it with a generator. So it's an overall solution than just only a single battery. So we're seeing a lot of that interest too.
Cool, cool, great. All right. And how about the company? Are they doing other stuff besides liquid batteries?
Well, right now, Etica AG is solely doing the immersion tech on the batteries, and that's what we're focused on.
Okay. And then what does that come from, Etica AG? What does that stand for?
Sure, it's actually a joint venture, and it's between Etica Battery, which is out of Taiwan,
Hmm.
and out of AGI, which is here in the US. And so together, they've joined a new company to get this technology out to the market.
And then AGI, to me, that stands like adjusted gross income. So I'll have to talk to my CPA about that. And so big batteries, are you doing like container size batteries, utility scale, all that kind of stuff?
Exactly. We do a container. It sits on a 20-foot footprint, and it does 3.06 megawatt hours. So we can take those and we can just chain them together to get really whatever capacity that you're looking for. And we also have a smaller product that's 340 kilowatt hours. And with the same thing, we can take those and we can link those together too. And then last, we have a residential product too.
Uh-huh. So it's like a 20-foot container. So the big ones are 40-foot. So it's like one of the smaller containers is what you have there. And that's kind of a lot of megawatt hours for that kind of footprint. And then you have something, what did you say, 300 and something kilowatt hours?
Yeah, we have a cabinet called the
Hmm.
power cabinet. It's 340 kilowatt hours.
And what size would that be?
That's actually dimensionally probably on about a 5 foot by 5 foot pad.
Hmm.
And that can be an AC solution or a DC solution.
Okay, great. And then how about the residential? Is that something that goes in the garage or?
The residential, if you put it in the garage, obviously it's too heavy to hang on the wall because of just the extra weight from the liquid. So it needs to sit on some concrete pad and such like that.
Yeah, and I suppose if you put it in the garage, you could multitask and you could do an oil change on your car and your battery at the same time.
Good idea, but wrong type of oil.
Uh-huh.
So you don't want to mix and match the oil. That's never good.
Yeah, okay, great, great. So that's pretty cool. And then so for the residential, did you say 20 kilowatt hours? Is that what size it is?
A little bit less than 20.
Okay, a little bit less than 20. And a lot of the residential batteries, like the companies, they'll show like, oh, it's a power wall and it's on the wall. And a lot of times they're just on the ground because they're kind of heavy, and so it goes on the ground. And what kind of footprint does that have?
Oh, it's actually a pretty small footprint, about 2 feet wide and only about 10 to 12 inches deep. And then height wise is about 4 foot.
Great. Okay, good. Well, I need to get a few of these for the solar training center.
That's a great idea.
Great. Good. Okay. Let's see. Is there anything else that you want to talk about?
I think we did good. I mean, we talked about the education component that we're doing, talking about bringing the technology here to the US. And then the UL 9540A is always an interesting discussion piece with everybody because it's not something that ever really happens. So I think we did pretty good.
Well, thank you very much, Matt Ward, president of Etica AG. And you can check out Etica AG at eticaag.com. And you can learn about battery immersion technology, which is the way of the future, right, Matt?
That's right, Sean.
Uh-huh.
Sean, thank you very much for having me on.
Yeah, and thanks for making it happen. Thanks for coming up with unique ways of doing energy storage and saving the world with renewable energy. And thank you, everybody else, for listening to Sean White's Solar and Energy Storage Podcast. If you want to get your NABCEP Energy Storage Installation Professional certification, you can be one of the first And go ahead, take my class. You can find it at solarsean.com/ESIP for Energy Storage Installation Professional. And have a great day, everyone. And thank you so much, Matt Ward, the president of Etica AG. Thanks, Matt.
Thanks, Sean.